Okay, so this video is on fractions, decimals, and percents. So we're just going to start out with a little lesson on fractions, decimals, and percents, and how they're really all the same thing. There's no difference between fractions, decimals, and percents. They're all the same way to represent parts of a whole. Okay? Now, parts of a whole. So if you have one thing, okay, say anything, we'll just say a block, something, okay? Now we already have numbers to represent whole things, okay? This would be one block, all right? This would be two blocks, all right? We're going to pretend those are the same size, okay? So we know about that. Well, fractions are just a way to represent parts of or less than one of a thing, okay? So the way we do that is we just divide our thing up into equal sized parts, okay? Now, let's just say that we didn't have a whole one of these, whatever they are, a block. Let's say we only had this much, okay? We only had 2 out of the 3. So a fraction is just 2 out of the 3. So you've got the number, this would be the number of parts, of equal parts, okay? Number of equal parts that you divide your thing into, okay? The total number of parts that makes up the whole, okay? So the total number of parts in the whole. And you just put that on the bottom. That's your total. We divided our one thing, we divided it up into 3 parts. And then it's just, you put that on the bottom, and on the top of the fraction, that's the number of parts that you have, or the number of parts you're concerned with. So in this case, whatever this block is, okay, let's say we have 2 of the 3 parts. So we have 2/3 of the block, okay, 2/3 of one block. So that's all fractions are, okay. Well, decimals and percents are essentially the same, okay. There's still ways to represent parts of a whole, and there are equivalents, okay. So we're just going to say, let's start out with an easy example. So let's say 1/10, 1/10, okay? So this is just a thing that's been divided into 10 parts, okay? Say this right here. Okay, that's 10 parts. We'll pretend like those are equal parts, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. So, and it's just one of those, okay? One of the 10 parts. So that's how you represent that. There's a thing that can be divided into 10 equal parts, and we have one of those parts, okay? So when you put something in decimal form, okay, what you have is you have the decimal places, right? It's all these different places. I'm going to put zeros, but they're going to be actual numbers, actually. We won't put zeros. So we're working with 1/10, 1. And then these zeros can go on forever, but you don't even have to write them. You don't need to write them. Just 0.1 or 0.1 is enough. So 0.1, even just 0.1, is fine with me. What these mean, these different decimal places, okay? So we have this first decimal place, second decimal place, third decimal place, fourth decimal place. They actually represent fractions, okay? And they're all over multiples of 10, okay? So this one tells you how many 1/10 you have. This one tells you how many 1/100 you have. This one tells you how many 1/1000 you have, and this one would tell you how many 1/10,000 you have. Okay? So if you were to take something and divide it up into 10 parts, and then you were to take that same thing, divide it up into 10 parts, take that same thing and divide it up into 100 parts. The one you divide into 100 parts, the parts are going to be much, much smaller, right? And we know that. So 1/10, so you take our little bar just like before, if we divided that into 10 parts, 1/10 is pretty big, okay? When you compare it to taking the same bar and dividing it a bunch of times up into 100 parts, one little hundredth is going to be like not even a line, okay? So they get, as you go down the decimal places, your numbers get smaller and smaller, but they get smaller very fast, okay? So fast, in fact, that if you take a line and draw it between any of your decimal places, okay, and then you think of all the numbers to the right of that line, and it could go on forever. If you totaled up all those numbers, it would never equal even one of these, okay? So that's how much smaller they get, okay? So 1/10 in decimal form is literally, this is the tenths place right here, it's just 1/10, okay? That's it. If it was 1/100th, it's just one of the hundredths, one in the hundredths place. Okay? So fractions and decimals, same thing. The way to find the decimal equivalent of a fraction is to divide this top number by the bottom number. So it'd be 1 divided by 100 equals 0.01, okay? 1/100th. So, percents. That is how a decimal becomes a fraction, or how a fraction becomes a decimal. That's what it means. But any fraction can become a decimal the same way. 2/3 can become a certain decimal. 2 divided by 3, it's like 0.66 repeating, I believe. But you do the same thing. You just divide the top by the bottom, and that changes a fraction into a decimal. When you're comparing decimals like 0.21589, say you were going to compare that to 0.3, and then that was it, it just stopped, you might be tempted to think that this one is larger, but no, because these first numbers in the tenths place are so much larger than the successive numbers. They dominate everything. So you just look at the first number. If you're comparing two decimals, you just take it number by number. So we look at our 2, and then we look at our 3. 2 is way bigger than 3. Well, it's 1 bigger. So 0.3 is bigger than 0.21589. This is actually 0.3000 on forever. We want it to go. Okay? So that's how you compare decimals. So it's easier, sometimes it's easier to compare fractions. You just take and turn the fraction and turn all your fractions into decimals, and you compare the decimals. Okay, so now percents. Percents are actually very easy if you know what the word cent means. Now a cent, you might think, is a penny, and you would be right. 1 cent is a penny. Okay? So 1 cent equals a penny. Well, how many pennies are in a dollar? 100. Okay? So there's 100 cents in a dollar. Cents means 100. There's the word century. Okay? Century. Well, century equals 100 years. So when somebody tells you per cent, It literally means per 100. That's all it means, per 100. Okay? So 95% is 95 out of 100, per 100. 95 per 100. That's what it means. Okay? If we continue with our 1/10, okay, well, 1/10 has an equivalent fraction out of 100. Okay? And that will be percent. 10 per 100, or percent, okay, so it's going to equal 10%, which is also going to equal 1/10, right? This is 1/10. So it's 1/10, 0.1. It's 1 in the tenths place. Now you might say, well, it was 10 100ths. It is 10 100ths. 1/10 is the same thing as 10 100ths, okay? So that is just how it goes. You can turn decimals into percents the same way. You do it the same way every time. Hold on just a second. I'm gonna knock at the door. Okay, I'm back. So that is percents, and that's anything. Okay, so you can go from fractions to decimals to percents. They all mean the same thing. So 1/10 is the same thing as 0.1 or 0.1, or this is actually called 1/10. You just make the direct translation, but it's 0.1, which is actually 10%. 10 per 100. 1 per 10 is 1 per every 10 is the same thing as 10 per every 100. Okay? So you can travel between these, between decimals and percents. You can just divide the top number by the bottom. That will give you your decimal. Once you have a decimal, okay, say we have 0.10, and there's as many zeros as we want to write. We don't have to write them, but we can. You change a decimal into a percent the same way every time. You take the decimal, you physically move it 1, 2 places. Now this is every time, every single time. You move it 2 places to the right. 2 places to the right. Okay? To the right. So if you have 0.234 even, okay, that's what you have. You had 0.234. We move it 2 places to the right. We have 23.4%. Okay? It started out here. It moved 1, 2 places. You move it 2 places to the right. You add the percent sign, and that is your percent. And you do that no matter what. No matter what. If you want to change a decimal into a percent, that's how you do it. If you want to change a percent into a decimal, you just do the opposite. So if you had, they gave you 23.4%, you move it 2 places to the left, 0.234 is your decimal equivalent. So that's it. So take this lesson and try to complete the homework. I'm going to go over them, but it's best if you can just take the general idea and then apply it to each one of them. Okay? So let's just start with number 1. We have to use these symbols, the greater than or less than, or the less than or greater than symbol, to compare these two fractions. Okay? Well, there's 2 ways we can go. We can't compare these like they are. Okay? It's really hard to see which one is bigger. because there's a different number on the bottom, different number on the top. We really don't know which one is bigger. So there's two ways that we can do this. There's probably more than that, but well, yeah, there's several. We could convert it to percent or whatever, but there's no need to do that. We can convert them both to decimals and just compare that. Or we can just change the fractions into two different fractions that have a common denominator. They'll be equal to to the fractions we have, but they'll have the same number on the bottom, and then we can just compare the number on the top, and that will tell us which one is bigger. So, for instance, we know we could change 5/8 into some number over 72. Hold on a second. Okay, we're back. So, I've decided, because I can tell by looking, that both 8 and 12 will go evenly into 72. It's a skill that you need to develop, but I know that 72 is a multiple of both 8 and 12. Okay? So 8 will go into 72 9 times. 8 times 9 is 72. Okay? So 8 times 9, 8 times 9 equals 72. Okay? And the way you change a fraction is you multiply the top and the bottom by the same number. So 5 times 9 is 45. 5/8 is the same thing as 45 over 72. Now, the way to change 12 into 72, multiply it by 6. 6 times 12 is 72. So, since we did that to the bottom, we have to do it to the top. 7 times 6 is 42. So now we have changed our fraction into two equivalent fractions, and now we can compare them. So 45 parts of something that's been divided up into 72 parts. So it's one thing, it's been divided up into 72 parts. Well, 45 of those is more than 42 of those. That's what getting the same number on the bottom allows us to do, is compare them. So we know 5/8 is bigger. So when you're using these symbols, it opens to the larger quantity. Okay? So 5/8 is bigger. So we pick that one. Another way we could do this is we could simply divide the top number by the bottom number. And that will give us decimals that are equivalent to our fraction, and then we can just compare the decimals. So we can just say, okay, we've got 5/8 and we've got 7/12. We can just divide the top number by the bottom number in both cases and see what we get. So 5 divided by 8, 0.625, and 7 divided by 12 is 0.583 repeating. Okay, now we know to compare these, we compare them one number at a time. So we compare the 6 to the 5. Well, 6 is bigger than 5, so we don't need to go any further. We know that this one is larger. But let's say if they were the same, we would just keep on comparing each number until one of them had a bigger number. Then you would know which one is the largest number. Okay, so number 2. What is 1/3 written as a decimal? Okay, well, we've already gone over how to convert these to a decimal. I encourage you to watch about the first 10 to 15 minutes of this video. So we have 1/3. Well, 1 divided by 3. That's how we do that. So we just divide the top number, or the numerator, divided by the bottom number, or the denominator. So you get 0.33, or 0.3 repeating. Okay? That's what the bar means. It means that that 3 actually goes on forever. So it's 0.33333, as many 3s as I could ever say, and a lifetime, and I wouldn't even be halfway there. So that's what the bar means. It means the 3 keeps repeating. That's what we have in our calculator. So you just represent it like that. So that is how you convert a fraction into a decimal. You just divide the top by the bottom, or the numerator by the denominator. Okay, so number 3. 7th grade teachers want 0.95 of their students to pass the test. What fraction of students is this? Well, okay, so we know we have 0.95. We know that's the tenths place, and that's the hundredths place. All right, so 0.95, if this is the hundredths place, what you can do is, for the last number you have, you take that place, okay? It's the hundredths place, and then you just write the numbers you have. Now remember, we have the imaginary zeros out through here, but we don't need to write those because they contain no information. So if we had, say, 0.951, when we convert that to a fraction, it would be 951 over 1,000, because the last number we have is in the thousandths place. Okay? Now, we don't see 95 over 100 as an answer choice. And the reason we don't is because this fraction is not in the lowest terms. Okay? So it needs to be in lowest terms. Okay? Well, the way you get a fraction in lowest terms, there's a couple of ways, but I think probably the easiest way is to just look at both the top number and the bottom number and try to think of a number you could divide evenly into both of them. Okay? So I can immediately tell 5 will go into both of these. That's the first number I can think of. Sometimes you'll have to do this repeatedly to get it down to the lowest terms. We'll see if that's the case on this one. So once you find a number that you know the top and the bottom number will divide evenly into both of those, then you actually just divide it by that number. Okay, so I divide the top by 5. I get 19. 100 divided by 5 is 20. Okay, so I get 19 over 20. Okay, I got that 20 by dividing 100 by 5. So you divide the top and the bottom number by the same number. That gives you some other fraction, 19 over 20, which actually happens to be one of the choices. Now sometimes, let's say if you had a number like 80 over 100, it might not be apparent, what number will go into them evenly, or you want to think of the largest number you can. But if you can't think of a large number, if they're both even numbers, 2 will go into them evenly. So you just divide both by 2. Okay, 80 divided by 2 is 40. 100 divided by 2 is 50. Okay, you can actually just keep on doing that. So divide them by 2 again. So 40 divided by 2 is 20. 50 divided by 2 is 25. Okay, well, 20 and 25 can't be divided by 2, but they both can be divided by 5. So if you divide the top and the bottom both by 5, you get 4 over 5. 20 divided by 5 is 5. Or 20 divided by 5 is 4. 25 divided by 5 is 5. So 80 over 100 is actually the same as 4/5. So, and that would be the lowest. This would be in lowest terms. Okay. So that's how you put a fraction in the lowest terms, which you're generally always going to have to do with your answer, and it will make your math easier if all the fractions you're working with you can put in lowest terms, because it just makes the number smaller. Okay, so on to number 4. What fraction is the largest value? Again, we could find common denominators for all these, or we could just change all of them to decimals. Okay, and by dividing the top number by the bottom number. So we would take 1 divided by 2. That would give us 0.5. Okay, or 0.50 or 0.5. We can take the second one, 3 divided by 5, gives us 0.6, 0.6, or 6/10. We take this third one, 4 divided by 6, that gives us 0.6 repeating. And finally, we take 7 divided by 12. That gives us 0.583 repeating. Now, we can just compare these. Okay, we can see which one is the largest. Well, we start right away looking at these two with the 0.6 because we know we start with the first number past the decimal point and we just compare those. So both of these have 0.6, so there are two largest numbers, and between them two, this one just has 0 that goes on forever and this one has 6. So we don't write the zeros, they're imaginary, but we know that they're there. So we look and see that they both have 6, and then we go to the next number. Well, one has 0 and one has another 6. 6 is certainly larger than 0. So this is actually the largest one right here. This is number 1, largest number. Okay. Well, we know the other two start with 5, and this one starts with 6, so this is our second largest number. Again, now we have two numbers that start with 0.5. This one has zeros, imaginary zeros that go on forever, right? 0.5000. Well, this one actually has numbers in those places. 0.83. Well, 8 is bigger than 0, so this is the third largest number, which makes this the fourth largest or smallest number. So, what fraction is largest in value? Well, this was numero uno, this was 0.66. We got that by dividing 4 by 6. So 4/6 was the largest number. All right, number 5. What fraction is the smallest in value? We do it the same way. We can just convert each of these to decimals the same way we did the last one. I'm not going to go over it again. Oh, actually, no, we're going to have to find a fraction. Excuse me. It's not b. Or maybe b, but we don't know that yet. We have to find a fraction. So what we're going to have to do is find the common denominator for all of these. Okay? So just by looking, I can go ahead and tell you that's going to be 12. That's the smallest number that I can see that I know is a multiple of 2, 3, and 4, which are all the numbers on the bottom. Okay? So we've got to change 1/2 into some number over 12. We have to change 1/3 into some number over 12. We have to change 1/4 into some number over 12. 2/3 into some number over 12. And last but not least, 3/4 into some number over 12. Now, we've already been over how to do this. You might want to rewind to the first maybe 10 to 15 minutes of the video. It goes over how to change a fraction. But what we do is we figure out what did we have to do to the bottom number to get this 12. And we just do that same thing to the top number. Well, what do we have to do to 6 to get 12? We had to multiply, excuse me, what do we have to do to 2 to get 12? We had to multiply it times 6. So 2 times 6 equals 12. We just multiply the top times 6. Okay, 1 times 6 is 6. What did we have to do to 3 to get 12? We had to multiply it times 4, right? 3 times 4 is 12. We just multiply the top by 4. 4/12. What do we have to do to 4 to get 12? We have to multiply it times 3. So we multiply the 1 by 3. We already know, we already did that. 3 times 4 is 12. So we multiply the bottom times 4. So we multiply the top times 4. Okay, both of them times the same number. 2 times 4 is 8. So that's 8/12. So we have 6/12, 4/12, 3/12, 8/12, and we didn't do this one yet. We have to multiply 4 times 3 to get 12, so we just multiply the top one times 3 and we get 9. Okay, so 9/12. Now, all of these are comparable. Okay, we have one thing that's the same size. It's been divided up into 12 parts. And in this scenario, we have 6 of those 12 parts. In this scenario, we have 4 of those 12 parts. We have 3 of those 12 parts, 8 of the 12 parts, 9 of the 12 parts. So if you have something, say a block of wood or whatever, and you've divided it up into 12 parts, you obviously have the least when you only have 3 of those parts. So the smallest in value is going to be the 3/12, which was created by changing 1/4 into 3/12. So 1/4 is our smallest number. Okay, number 6, Ann stated that the equivalent fraction to 0.125 is 2/3. Did Ann state the correct equivalent fraction? Let's find out, because we know we can change a fraction to a decimal by dividing the top by the bottom, right? So 2 divided by 3, 0.66 repeating. Well, I don't know about you, but 0.125 does not look like 0.66 repeating. So Ann did not state the correct equivalent fraction. Okay, so Adam, Dave, Kyle, and Dan gathered 100 eggs from the hen house. The table shows what part of the total each person gathered. Which lists the names in the order of the person who gathered the most eggs to the person who gathered the fewest eggs. So the most eggs would be the largest number. The fewest eggs would be the smallest number. So really all they're asking us to do is compare each of these and see which one is the smallest and which one is the biggest, and all in between, and put them in order from largest to smallest. Okay? So who gathered the most eggs would be the largest number, the fewest eggs would be the smallest number. So all we have to do is change these into the same format. We can change them all into fractions, we can change them all into percents, we can change them all into decimals. Typically it's easier to just change them all into decimals. So we know how to do that. We've been doing that a while. 1 divided by 4 is going to be 0.25, or 25 hundredths, 2/10 plus 5 hundredths. This one, luckily, is already a decimal, so 0.31, 26%. We know when we want to change a percent into a decimal, we just pretend that there was a decimal there, and we move it 2 places to the left every time. 2 places and only 2 places every single time. Never move the decimal any more or less than 2 places to the left when you're changing from percent to decimal. Okay? So, and we know to change a decimal to a percent, we move 2 places to the right. This would be 31% right here. But that's not what we're doing. We're changing them to decimals, so 26%. If we move the imaginary decimal that's not showing 2 places to the left, we'd have 0.26. So we just need to change this last one into a fraction. We do that by dividing the top number 9 by the bottom number 50, which would give us 0.18 for the numerator by the denominator. Okay. So what do we have? We have, here's the largest one right here. So we're going to say that's 1. Well, what's the next biggest one? Okay. Well, 2 of them have 2 as the first number. Well, those are our next candidates because 2 is definitely bigger than 1. So since they both have 2 in the 10th place, then we go to the 100th place. And we look at what number is there. Well, 6 is bigger than 5. So we know 0.26 is bigger than 0.25. Okay, we know 0.25 is bigger than 0.18. And we know 0.18 is our smallest. So now we've ranked them. Okay. Now we know that it should be Dave, then Kyla. Oh, excuse me. Let's be the 4th person. Then Adam, then Dan. So do we have that? I think we do. It looks like Dave, then Kyla, then Adam, then Dan. D. Okay, number 8. The table shows the number of pies eaten by the top 4 contestants in a middle school pie eating contest. Well, this is what's called a mixed number. So this is red 5 1/2. So Ali has eaten 5 1/2 pies. Okay. Well, you can tell that they all ate 5 pies and then some part of another pie. Okay, so they all ate 5. But then they ate part of another pie. So whoever ate the largest part of that next pie, that 6th pie, that's who ate the most. So, but we want from least to greatest. So we need to just go ahead and change these into decimals. Now, we know we have 5 whole. They eat 5 whole pies. So each one of them, it's automatically 5 point something. Since this top number is smaller than the bottom number in every case, we know that this fraction means less than 1. So they never ate more than 5 or more than 6 pies. They ate at least 5 and not quite 6. So we just had to figure out who ate the most. So let's just change this part into a decimal, and we'll write whatever decimal we get in our decimal places here in each one of the things. Okay? So we just know that 1 divided by 2 would be 0.5. So this is 5.50 or 5.5 or whatever that we can read it, 5.5. Okay, so 1 divided by 4 is 0.25. 5.25. 2 divided by 3 is 0.66. Repeating, okay? The 6 actually goes on forever. And 3 divided by 8 is 0.375. Okay, so now we have our numbers. Now we can rank them. We know all these 5s are equal, so that doesn't tell us who ate the most because they all ate 5 and then some part of another pie. So now we must go to this first decimal number and look at those and compare those. So I see a 6 here, and that is the largest number. So this person ate the most pies. Okay? Now we go on to the second number. I see a 5 here, and that's the largest number. This person ate the second largest amount of pie. Now we go here. We have a 3, which is bigger than the 2, which is the only other one remaining. Let's look at the first ones, that 3 and that 2. I can see that the 3 is bigger, so this is the third largest amount of pie, and then this person came in last. So it looks to me like we're going from least to greatest. So if this person came in last, they eat the least pie, so they're actually going to be first in our list, okay? And then we go down from there. So this is the second person. So it looks like it's going to be Brett ate the smallest. Then Zeke. And then we go to, or excuse me, I'm sorry, not Zeke. Wrong one. Ali. Right? Because we started at. No, I was right. Yeah, smallest. So, excuse me. Brett was the smallest. Okay, the smallest pie, so he's going to be first. Okay, the next smallest is going to be Zeke. Then the next smallest after that is going to be up here. It's going to be Ali. And then finally Lois. So it's going to go Brett, Zeke, Ali, Lois. Well, do we see that? Do we see Brett, Zeke, Ali, Lois? Brett, Zeke, Ali, Lois. It looks like we do. All right. So what fractions are equivalent? It means what fractions equal each other. We've shown how to change fractions into other fractions. So we just need to see, well, which ones of these are equal to each other? Well, we know if you have one, if this is the number of parts that make up the whole thing, okay, well, if you have something divided into 2 parts and something divided into 3 parts and something divided into 4 parts, the thing you're dividing is the same size, okay, but you've divided it into different numbers of parts. So if you take one of those parts out of each of these things that you've divided into different numbers of parts, well, these can't be equal because one of those parts cannot be the same size as one of another part. So if you take something and you divide it into 2 pieces, and then you take that same equivalent something the same size, and divide it into 3 pieces, well, obviously the pieces are going to be different sizes. So one of each one of those pieces will not be the same size. So 1/2, 1/3, and 1/4 we know are not equal to each other. It cannot be. Okay? So that leaves us with 12 over 24 and 14 over 21. Now, these are in lowest terms because they cannot be reduced anymore. Okay? both of the top and the bottom. The only thing that will go evenly in both of them is 1. So once you get where there are no more whole numbers that can divide into the top and the bottom evenly, then they are in lowest terms. But we can see that these two are probably not in lowest terms, okay? So I'm going to look at 12 and 24. Well, what is the largest number that can divide evenly into both 12 and 24? Well, it's actually 12, okay? Because 12 will go into 12 one time. 12 will go into 24 two times. Well, actually, we don't need to go any further, because 1/2 equals 12/24. We change that by dividing the top and the bottom by the same number, in this case 12. And it just happens that 12 is one of our numbers. 12 divided by 12 is 1. So since 1/2 is the same as 12/24, well, we have 1/2 here. So we know 1/2 and 12/24 are the same number. Number 10, John must find a decimal and a fraction that are equivalent to each other. Of the decimals and fractions listed, which two are equivalent? Okay, so if this doesn't immediately pop out at you, then I invite you to go back and watch about the first 10 minutes of this video. We kind of go over changing between the different forms of fractions, decimals, and percents. If you watch that, you would know that this is the 10th place. Okay, this first place past the decimal is the 10th place. So since we know that, 0.7, since 7 is in the 10th place, 0.7 means 7 tenths. That's exactly what it means. So 7 tenths is 7 tenths. 7 tenths is 0.7. Okay, so review the first 10 minutes. It covers sort of how to do that. All right, so find the product of 3/4 and 2/5. Now, product is basically the answer to a multiplication problem. Okay, so when you multiply two numbers, what you end up with is the product of doing that. Now, how do you multiply fractions? It is not hard at all. All you do is multiply the two top numbers times each other. That will give you your new top number. 3 times 2 is 6. Then you multiply the two bottom numbers by each other. 4 times 5 is 20. So 6/20, but you'll notice we don't have that as an answer choice. That's because we have not put our answer into lowest terms. Now, how do we put it into lowest terms? Well, I've got to think of a number that will divide evenly into both the top and the bottom number, into both 6 and 20. The first thing that jumps out at me, and a lot of times it is the first number that jumps out, if you can reduce a fraction, it's just going to be 2. I know I can divide both of these by 2, so that's what I do. I don't sit around and try to think of the biggest number. That is, you want to call it the greatest common factor. And if I could think of the biggest number right ahead, actually I think this is the biggest number, but even if it was some other numbers and 2 was not the biggest numbers, well, 2 is still a number, and it still lets us make some progress. So I can go 6 divided by 2 is 3. 20 divided by 2 is 10. So 3 tenths. And actually that cannot be reduced anymore. The largest number that can divide evenly into both of these is 1. And that wouldn't help us, because 3 divided by 1 is 3, and 10 divided by 1 is 10, and then we would still have 3 tenths. So, but that is one of our answer choices. Answer choice B, 3 tenths. Number 12, find the product of 2 and 1/2 times 3/4. So this is a mixed number. We know this means 2 and 1/2, or 2 plus 1/2. Okay, either way you want to do that. But we change a mixed number, 2 and 1/2. We need to change that into a fraction, because we cannot multiply this as it stands. We don't know how to do that yet. So we need to change this number into an improper fraction. Now it's a mixed number. Any improper fraction is a fraction where the number on the top is bigger than the number on the bottom. Excuse me. And they're always equal to 1 or more than 1, actually. So the way we change a fraction or a mixed number into an improper fraction is we just multiply the number on the bottom times our whole number, and then whatever we get, we put that over the number on the bottom. Now, what do I mean by that? I mean, literally, you multiply 2 times 2. That's 4, and then we just stick this number under the bottom. That's 2. Then you add it to your fraction part. Okay? So you get your whole number part and your fraction part. Take the bottom of your fraction part and multiply it times your whole number. That will give you some number. Then you just take your fraction part and put it on the bottom, right here. Then add it to your whole fraction part. 4 plus 1 is 5. You might be tempted to add 2 plus 2, but that's not what you do. You just add 4 plus 1 right here, and you leave the 2 the same. So it's 5 halves is the same as 2 and 1 half. Well, now that we know that, we can simply multiply like we did before, which is straight across, okay? Not like here, when we added, we left the bottom number the same. The denominator stayed the same, and we just added the top numbers. Here, we actually multiply both the top and the bottom. 5 times 3 is 15. 2 times 4 is 8. 15 over 8. Now we have to change it back into a mixed number, okay? So we have to figure out how many times this bottom number goes into this top number. Well, it won't quite go 2. You can see that because 2 times 8 is more than 15. And we're going to have to pause. I'll get back to this later.